So I'm Steve. I work at Axiom Zen in Vancouver, British Columbia, Canada. Apologies, firstly. This talk is going to be in English because my Spanish is no bueno. So I know the talk description said VIPER. It's not actually going to be a talk specifically about VIPER, but it will revolve around VIPER. So VIPER, also known as what have I gotten myself into? Preamble. It's ostensibly about VIPER, but it's actually more about my experimentation with different architectures. This talk is not prescriptive. I'm not going to talk about what you should do. It's more about the approaches I took, and maybe I can give you some ideas on things you can try to find an architecture that works well for you. So a quick history. There's a guy named Robert Martin, aka Uncle Bob. He came up with an idea called clean architecture. And this is a set of rules that he derived from a bunch of different architectures that he liked, took all the good pieces, and used that to describe this list. Years later, a company called Mutual Mobile came around, and they came up with a clean architecture implementation for iOS called VIPER. Is VIPER the last architecture you'll need? Probably not. So I'll start with a review of common architecture patterns on iOS. The oldest and most common is MVC. It was originally introduced in 1988. Who's familiar with MVC? Okay, good. So model view controller, model contains data, view displays data, and the controller does everything else. So the model and the view are both dumb, and the controller has all the brains. This is what it looks like. These boxes aren't actually necessarily objects, they're layers. But in the case of a screen in iOS, your controller is going to be your view controller. This is going to be your view controller's view, and it's going to display whatever model you need to display for that screen. So when I say controller, I'm probably going to be talking about view controller from now on. Next is MVVM. Who's familiar with this? Okay. This was introduced in 2005. Stands for Model View View Model. Models and views are the same as before. Controller is still there. It's just not in the acronym. And we've got this new object called a view model. Well, object or layer. It handles the presentation logic. And so what that means is it does all the conversion of data needed to be displayed inside the view. So that could be turning an NS state into a string so it can go into a label. But as you'll notice, the view controller got smaller. And that's good because it makes it easier to unit test. So in MVC, models can be tested, but there's not really much there to test because they should be really, really dumb. View controllers are difficult to test because they have to create and control the views, and they're big and they're bloated, and you can't test specific pieces very easily, and you can't test them quickly. Views you just don't test because there's no pure logic in there. But by moving to MVVM, this piece entirely takes logic that would otherwise be in the view controller, and now you can write tests for it. You can test the input and the output completely. Feeding data in is very simple. Then came VIPER, introduced in December 2013, so it's just over 2 years old now. Who's familiar with VIPER? Okay, it stands for View, Interactor, Presenter, Entity, and Router. So, the view displays data, the entity contains data, the presenter contains presentation logic, and then we have these two new layers. You'll notice that this is basically the same as MVVM before. Model and view model, entity and presenter. The interactor contains business logic, and the router contains navigation logic. Additionally, there's a data store, which handles persistence logic, but it didn't fit in the acronym. And the view controller is still there, not in the acronym either. So what do? The interactor takes business logic from the view controller into a new separate layer. It handles all the logic for a screen that has nothing to do with UI. So it's logic for use cases for a module. It could be, if it's a sign up module, handles logging in, the logic for signing up, creating a user, resetting a password. The router, logic for what to present and how to present. So it's very similar to the coordinator you just heard about. It decouples view controllers. It chooses which to push, how to push them if it's presenting modally, and the different screens don't need to know about each other. The data store is logic for retrieving and saving entities. So really what it does is it provides the entities to the use cases or the interactors. And then when the interactors modify those entities or data objects, it stores them again. So what have we done? We've gone from a view controller that handles all the logic to a bunch of smaller purpose-driven layers where each handles a specific type of logic. And the view controller still does everything else, but it's a lot less. So that's VIPER. What does it look like? We went from MVC to MVVM to VIPER. This is called a module. It usually represents a feature or a screen. The router creates everything and hooks everything up. So you have the view, the presenter, which is your view model, the interactor, which handles most of the logic, the data store for persistence, and then you've got your model. I started with this architecture last summer for a medium-sized application, and immediately I ran into problems, right? It's not perfect. There are major problems. So now I'm going to tell you about how I fixed that. Well, not entirely, but how we improved it slightly. So how can we improve it? Some layers still do too many things. So let's split the router into a router and a wireframe. So here, rather than having the router create everything and handle navigation, let's have the router just do navigation, and the wireframe will create the module, so it'll initialize all those separate layers, hook them up, and then it is also the boundary for communication back into the router to ask it to display a different screen. So in this case, this is the wireframe, and the router will be somewhere up there. Also, the data store. Let's split that up into 3 layers. A data manager, networking layer, and a persistence layer. So persistence firstly. Logic for conversion between in-memory data structures to database objects. Logic for executing queries and finding those things, fetching those objects. And then also logic for writing stuff to the database. This could be wraparound core data or realm or even just a property list. It doesn't matter. Its job is to abstract that from the rest of the application. So the application asks it to save something, and how it gets saved, it doesn't matter. I label it cache because persistence won't fit, but it's the same thing. Networking. So this is the logic for creating and formatting network requests. It also handles the responses and how to convert JSON into native types. It could be a wraparound NSURL session, AF networking Elmo fire, doesn't matter. The application asks it to do something to hit a certain endpoint. It formats everything and handles that. It hides all the implementation details. That is it down here, the API. Finally, the data manager. Logic for when to hit the cache or the persistence and when to actually reach outside the app and hit networking. It provides the parsers to the persistence to convert types and dictionaries into actual models. It provides formatters for networking to get the right JSON in the way that the parsers are expecting. It could be retrieving data from the network. It could be grabbing it from persistence. You don't know. You don't really care. You just ask it for, give me the session object, give me the user object, and it gives it to you. And so it sits here controlling both of those. So now we've gone from 4 layers, each with a specific responsibility. 7. We've got navigation logic, module logic, which is just creating a module, setting everything up. The presentation logic, creating data or converting data so that views can display it. Business logic that operates on all the use cases you need to do for a particular screen. Caching logic, networking logic, and persistence logic. Who thinks this is too much? Who thinks this is a good separation of responsibility? Who thinks this would make it easier to split up work on a team? Who thinks it'd be easier to test? who thinks it'd be easier to reuse specific layers in different screens. That's kind of the point. Different screens, the module talks to the router, and just like you saw with the coordinators, pushes the next screen on. You may have noticed I had view controller up there. It's because our view controller already knows about the view and has to create it. It's coupled with, storyboards and zibs. I thought may as well make that into the wireframe. So give it a router. It handles creating and linking components and hooking them up, and that looks like this. It's not pretty, but it worked for a while. So it creates each of those, hooks them up, and communicates with the router. The router is responsible for creating the wireframe and then presenting it. Benefits here: testable, reusable, parallel development, and easier to understand. So, testable. Each of these pieces can be tested separately and wholly. You don't need to just poke into the view controller and hope that something good happens and that you can test it. Reusable. Smaller objects, more likely to be useful elsewhere. Parallel development. I can give each one of these to a different person on the team and they can work on it at the same time. And easier to understand. Easy to explain what a networking layer does, hard to explain what, say, a profile view controller does if it does all of this stuff. How can we improve it further? The components still know too much about each other. So let's introduce protocol boundaries. Here we replace explicit references to class types with abstract protocol boundaries. So here, where you'd normally talk to the one router in the app, which has all those methods that can be communicated with, replace it with a protocol that limits what this class can see. It can only see the ones that were meant for it, and you can't accidentally call the wrong method. Additionally, the wireframe has its own type and implements that as an extension, so things that need to communicate with the wireframe only see what they need to. Further down the chain, we've got a linking of objects like this. Rather than talking to each other directly, we create boundaries at each entry or exit point. What does this let us do? You can create a unit test that tests this object completely, input and output. So it's testable. It's more reusable because this object could be taken out, you could put a new object in there, and as long as it has the same conformances to the protocols, it just works. Parallel development again, we define protocols with my team members. Somebody works on one side of it, somebody works on the other, and they just link up nicely. Additionally, they act as headers. So if I look in a class, I want to know what it's doing. Instead of going and reading through the whole file looking for the internal or public methods, skipping over the private ones, I look at the top of the class and I can see everything that this class can do in these different scenarios. You might be asking, won't we end up with lots of protocol boundaries? Yeah. If you're doing it right, you'll have tons. They'll be small, but you'll have a lot of them. You'll have small ones and then bigger ones made up by combining smaller ones. And that's a good thing, but can we improve it further? Data is flowing in too many directions. If we apply a more top-down approach, you'll see currently each of these has a reference to multiple objects. Each one of these needs a protocol boundary. What if we change it like this and just had closures to return data? Much simpler, half as many entry and exit points and boundaries required. What does it do? It reduces complexity. Debugging a chain like that, going down and then looking in the closure is much easier than finding which protocol is pointing to which protocol and back. Memory management. Before, you'd have to manage weak and strong references, otherwise you get a retain cycle because you've got objects pointing at each other. This way, The top one owns the next one. That one owns the ones below it. Super easy. Don't even have to think about it. More maintainable. If you need to change requirements, rather than going and changing 4 protocol boundaries, you might be required to change 2. Additionally, with dependency injection, before we'd have to have internal vars. Now we can have private lets. This results in cleaner objects. We can also remove optionals in that case. And now you don't have to unwrap everywhere, which is safer and cleaner. So now, with dependency injection, each one's inserted into the next. Much cleaner. Is there anything else we can do? Well, initially I'd merged the wireframe and the view controller together, but turns out merging the view and the view controller is a better option. View controllers provide very important view lifecycle information. They're already tightly coupled with storyboards and zibs, so you may as well remove that extra logic and put it in a separate wireframe class. Here we've got a dumb, could be struct, could be class that handles initializing everything. You also get to use dependency injection on the view controller and initialize it with whatever properties it needs. Much cleaner. We can also split interactors up by use case. So, have one interactor for fetching user objects, say, one for updating the user object, one for deleting the user object, and then if a module needs to do 2 or 3 of those, have a module interactor that combines those and is just a wrapper. That way, if you need to fetch user objects on a different screen, you can reuse that one individual piece, and it's easier to test. Lastly, we can split the router into coordinators, as was mentioned. The router is generally a very big class, and rather than using one massive router to handle navigation for the whole app, split it up into coordinators for each section. So you could have a coordinator for your login flow, for your onboarding flow, for settings, for your main profile flow, if it's a chat app, whatever. So finally, we've arrived here. Our last block diagram. Interactors are split up. Wireframe separate from view controller, which is now in the view layer. We've got a main app coordinator, which coordinates all the smaller coordinators, and those talk with the wireframe. We went from originally all these sort of dependency arrows like this to something that is got more blocks in it, but it's much easier to understand. It's much simpler. There's only one arrow going in the direction. So this was just an experimentation with VIPER for me. One of several different architectures that I tried, and they're all inspired. We're always trying out new things, and not every architecture is going to work for every project. So each time you start a new project, I highly encourage you to go forth and experiment and try something new. Take inspiration from a bunch of different architectures you like and know, take the best pieces, and try and make something new. So I have to acknowledge Uncle Bob, great reading, Mutual Mobile for coming up with VIPER in the first place, and my coworkers for always listening to me talk about architecture. Thank you. Any questions?
How do you handle when you have a new format, for example, for any of the sections of your model?
If we're modifying the model?
Yeah, for example, you have a new data management layer. Data management block. So how do you how can you handle that new version, for example, that adds new functionality or something like that?
So the data manager uses 2 different things. It uses formatters to format the data coming in from the networking layer, and it uses parsers to convert that into model objects that can be persisted by the persistence layer. So you don't need to modify your data layer much. You don't need to modify your persistence or networking layers at all. You create a new parser, a new formatter, and use those instead. And those are generally very small.
Did you teach this to your team? Are you actually using this right now?
Yeah, I browbeat them pretty heavily. They use it.
But the response, the time to learn, and that stuff, I think it's like overwhelming. It looks great, but
It is. It's pretty dense, right?
Yeah.
But the more you get used to it, you see it in code reviews. You talk about it in your team meetings. You get people to try out their version of it on a project, and eventually, we don't all agree on the same thing, but we're all trying different things and then bringing it back and sharing it with each other.
Cool.
Wait. You get pretty used to like, well, actually at the beginning I didn't like this shit because it's way too much. But after a while you get used to like every time you start like a new like file, new class or something, you start like writing the protocol right away. Like this is gonna be my protocol. It's as Steve says, like this is gonna be like my header. This is what I expect to do. Then you write your like class. Could be like pretty stupid at the very beginning. Like okay, init with I don't know user. I don't care. And then you say like okay, then my class is gonna extend this protocol, use it, and you start implementing your real class in the extension of your protocol. So at the beginning was like, oh, what, really? But now it's part of like how I program, I guess. Thank you, Steve.
Is it better or worse than before?
A bit better.
Okay, gracias chicos. Un aplauso para Steve.
Thank you.